Hey Becca, what are we learning today?
Today, we're going to convert rectangular coordinates to polar coordinates. We are going to be converting rectangular coordinates, x comma y, to polar coordinates, r comma theta. Now x comma y uses the x and y axis. X is our horizontal shift and y is our vertical shift that will take us to the point we're looking for in the coordinate plane. R and theta are different axes. R is the distance of the point to the origin. So R is this distance on the diagonal, and theta is the angle measurement from 0 degrees, the angle of elevation of our segment here. So we have to relate x and y to r and theta in order to convert our coordinates. So if we draw a triangle where our x is our horizontal movement, y is our vertical movement, r is our diagonal, and theta is our angle of elevation, then we can use formulas that we've seen before in order to relate x, y, r, and theta. The first formula that we'll use is the Pythagorean theorem. X squared plus y squared equals r squared. So using x and y, we can find r. The second formula that we're going to use is a trig function of theta, and the trig function we're going to use is tangent, because tangent of theta will bring in the y that we know and the x that we know. Tangent of theta is opposite over adjacent, y over x. So this formula will let us use y and x in order to find theta. In this first example, we're going to convert 0, 1 rectangular coordinates to r, theta polar coordinates. Now, if we look at 0, 1 on a graph, 0 in the x direction, 1 in the y direction, we can figure out our r and our theta just by looking at this graph. If our radius is the distance from the origin, that's just going to be this vertical distance here, which we know is 1. And theta is the angle from 0 degrees, and if we go all the way up to the vertical, that's just a 90-degree angle. So our theta will be 90 degrees. But we're going to use these formulas to verify that this will work for this example. So let's use this Pythagorean theorem formula to find r using our x and our y. X squared is 0 squared, y squared is 1 squared, equals r squared. 0 squared is just 0, 1 squared is 1, equals r squared. And if we take the square root of both sides, r equals 1, which is what we got when we looked at the graph. We're also going to use the tangent function in order to find the theta that we're looking for here, using y and x. Tan of theta equals y, which is 1, over x, which is 0. But we can't have a 0 in the denominator, so this tangent is going to be undefined. Using the unit circle, we know that the tangent of theta is undefined when cosine equals 0, but sine equals anything other than 0. Where does cosine equal 0? Well, cosine will equal 0 when theta is 90 degrees because cosine is the x shift on the x and y plane, and when cosine is 0 in the unit circle, sine is 1, and that will be at our 90-degree angle. So r is 1 and and theta is 90 degrees. So when we write our polar coordinate, 1, 90 degrees. Here's another example where we're going to convert 2, 3 into polar coordinates. Let's use the Pythagorean theorem to find r. X squared would be 2 squared plus y squared 3 squared equals r squared. 2 squared is 4 plus 3 squared is 9 equals 13, which is equal to r squared. If we take the square root of both sides, r is going to equal the square root of 13. We'll use our tangent formula to find theta. Tangent of theta equals y over x, which is 3 over 2. So in order to find theta, we have to take the inverse tangent of both sides. And if you plug into your calculator the inverse tangent of 3 over 2, you'll get approximately 56.31 degrees. So that's going to give us our theta. So 2, 3 in polar coordinates is root 13, 56.31 degrees. This example, we're going to convert -4, 7 into r, theta. We're going to use the Pythagorean theorem to find r. -4 squared plus 7 squared equals r squared. -4 squared is 16 plus 7 squared is 49, and that gives us 65, which will equal r squared. So when you take the square root of both sides, r equals the square root of 65. Now let's find tangent of theta. And that equals y over x, which is going to be 7 over -4. If you plug in inverse tangent of 7 over -4 into your calculator, you should get approximately -60.26 degrees. Now let's not be so quick to accept this as our answer, because if you look at the coordinate plane, -4, 7 is somewhere in the second quadrant, because our x value is negative and our y value is positive. But if you look at -60.26 degrees, that's going to fall in quadrant 4 over here. So we want the angle that's going to be in quadrant 2 but coterminal to this angle. So how do we get from quadrant 4 to quadrant 2 where the tangent of theta will still be the same? We have to take our angle and add 180 degrees to our angle. And if you do that, the new angle that we get is 119.74 degrees. And that makes more sense because our r is our distance from the origin, square root of 65, but our theta is 119 degrees from 0, which should fall in the second quadrant. So negative 4, 7 converts to square root of 65, 119.74 degrees. In this last example, we're going to find the polar coordinate that corresponds to 1, 1. Using the Pythagorean theorem, x squared, 1 squared, plus y squared, 1 squared, equals r squared. The left-hand side, 1 plus 1 is 2, equals r squared. We take the square root of both sides, r equals the square root of 2. Using our tangent formula, tangent of theta equals y over x, 1 over 1, which is just 1. So using our unit circle, where does the tangent of theta equal 1 when the sine of theta equals the cosine of theta? And that only happens at one angle, and our angle is 45 degrees, or pi over 4 radians. And let's just verify our answer. 1, 1 is up here. The distance from the origin is the radius, square root of 2. And this will be a 45-degree angle from the 0 degree measurement point. So our polar coordinates, square root of 2, 45 degrees.
After watching this video, I hope it's a little bit easier to convert rectangular coordinates to polar coordinates. If you found it helpful, give it a thumbs up and subscribe because we're posting new videos every Monday and Thursday. Bye!